track's gone.
It just vanished.
October 24th, 1984. Murmansk, Soviet Union. Captain First Rank Dmitry Volkov stood in the operations center of the Northern Fleet Submarine Command, watching something that should not exist. The massive display board showed the Barents Sea, a grid of green phosphorescent lines marking known NATO patrol patterns, Soviet exercise areas, and the invisible boundaries of territorial waters. For the past 6 hours, one of those lines had been behaving impossibly. The K-239, a Project 671 RTM Victor III class attack submarine, had been running a standard surveillance patrol along the GIUK Gap, that critical stretch of ocean between Greenland, Iceland, and the United Kingdom. It was the choke point, the gateway between Soviet naval power in the Kola Peninsula and the open Atlantic. Every Soviet submarine had to pass through it. Every NATO hunter knew to watch it. Captain Second Rank Yevgeny Petrov commanded the K-239. He was a careful man, methodical, a protege of Volkov's own. His orders were simple: remain undetected, monitor NATO surface traffic, and return to base in 14 days. The K-239 had been operating for 9 days. Its last scheduled communication was 4 hours ago, a brief burst transmission confirming position and status. All nominal. Then the anomaly began. "Comrade Captain," the duty officer's voice was tight with confusion. "Severomorsk SOSA station reports acoustic contact. Classification, Project 671 RTM. Bearing and signature match K-239. Volkov's blood went cold. SOSUS. Sound Surveillance System. The Americans' underwater listening network, a chain of hydrophones strung along the ocean floor from Greenland to Norway. The Soviet Navy knew about SOSUS. They had studied it, mapped it, feared it. And they had spent billions of rubles designing submarines that could slip past it. The Victor III was supposed to be that submarine. It had a new anechoic coating, rubber tiles that absorbed sonar pings. It had a 7-bladed propeller designed to eliminate cavitation noise. It had rafted machinery, every pump and motor isolated on rubber mounts to prevent vibrations from reaching the hull. On paper, the Victor III was nearly as quiet as the Americans' vaunted Los Angeles-class boats. On paper, SOSUS should not be able to hear it. "Are you certain?" Volkov demanded. "Yes, Comrade Captain. The signature is unmistakable. They have had continuous track for 6 hours. 6 hours. Not a brief detection, not a lucky passive ping. Continuous track. The Americans could hear K-239 as clearly as if it were a diesel boat running on the surface with engines bellowing. Volkov grabbed the secure telephone. "Get me Captain Petrov. Now." The radio man's face was pale. "We have been trying, Comrade Captain. K-239 is not responding to scheduled communications." "Emergency protocols?" "Nothing. Complete radio silence." The room seemed to tilt. Volkov's mind raced through the possibilities, each more horrifying than the last. Catastrophic failure? The submarine was operating normally 6 hours ago. Mutiny? Absurd. Defection? Petrov's family was in Leningrad. He had a daughter in university, a son in the Naval Academy. "Pull their last known position," Volkov ordered. "Compare it to the SOSUS detection coordinates." The duty officer worked his calculations. When he looked up, his face had gone from pale to gray. "Comrade Captain, they match. Exactly. The Americans are tracking K-239 in real time." Volkov felt the weight of the moment settling on him like a physical force. This was not just one submarine. This was the entire Soviet undersea doctrine. If the Americans could hear the Victor III, their newest, quietest boat, then they could hear everything. Every boomer carrying R-29 missiles, every attack sub hunting American carriers, every vessel the motherland had built to contest control of the seas. "Send the recall signal," Volkov said quietly. "Emergency ascent protocols. Bring her home." They transmitted the signal on every frequency. They used the ELF arrays, the extremely low-frequency antennas that could punch through thousands of meters of seawater. They broadcast continuously for 3 hours. K-239 never responded. At hour 7, the SOSUS contact changed. The submarine's acoustic signature showed rapid acceleration, a hard turn to starboard, depth increasing. The profile of an emergency dive, a boat running for its life. Then, at hour 8, the signature vanished. Not faded, not gradually lost in the ambient noise of the ocean, just gone, as if someone had thrown a switch. The Northern Fleet Command Center erupted in controlled chaos. Volkov issued orders, his voice steady despite the dread pooling in his gut. Surface ships were dispatched. Maritime patrol aircraft scrambled. Rescue submarines were put on alert. But everyone in that room knew the truth. They had just watched a submarine vanish, and before it disappeared, the Americans had been able to hear it, track it, and follow it with a precision that should have been impossible. At dawn, a coded message arrived from Moscow. The defense minister himself had been briefed. A special commission was being formed. All submarine operations in the North Atlantic were suspended pending investigation. The message ended with a single line that made Volkov's hands shake. "Determine how the Americans are detecting our boats. Determine what happened to K-239. Failure is not acceptable." Captain Dmitry Volkov stared at the blank display board where K-239's track had been. He had commanded submarines for 20 years. He had hunted American carriers during the Cuban Missile Crisis. He had played cat and mouse with NATO destroyers in the Mediterranean. He knew the ocean. He knew its sounds, its silences, its secrets. But this was something new. This was something wrong. The Americans weren't just better at the game. They had changed the rules entirely. And somewhere in the black depths of the Barents Sea, Yevgeny Petrov and his crew of 94 men were gone. Vanished. As if the ocean itself had swallowed them whole. The mystery had just begun. Moscow, Ministry of Defense, November 3rd, 1984. Vice Admiral Sergei Gorshkov sat at the head of a long table in a windowless conference room deep beneath the Ministry of Defense. At 74 years old, Gorshkov had spent the past 3 decades building the Soviet Navy from a coastal defense force into a true blue water fleet. He had argued with Khrushchev, negotiated with Brezhnev, and survived every political purge. He was untouchable. But the papers spread before him now made him feel very, very mortal. The loss of K-239 had not been an isolated incident. Over the past 18 months, 6 Soviet submarines had vanished or been compromised in the North Atlantic. 6. At first, each incident had been treated separately. Accidents happened. The ocean was unforgiving. Equipment failed. Human error occurred. But the intelligence officer standing at the front of the room, a thin, nervous GRU colonel named Anatoly Surikov, had done something no one else had thought to do. He had mapped them. On the wall behind Surikov was a chart of the North Atlantic. Red pins marked the last known positions of the missing submarines. Blue pins marked the locations where SOSUS had detected Soviet boats that subsequently went silent or were forced to abort their missions. The pattern was unmistakable. "Comrade Admiral," Surikov began, his voice steady despite the tremor in his hands. "We have identified a distinct operational pattern. Each incident occurs in international waters, beyond the range of our maritime patrol aircraft. Each occurs in deep water, between 2,000 and 4,000 meters. And each occurs in areas where NATO has recently conducted so-called oceanographic research." Gorshkov leaned forward. "Explain." Surikov clicked to the next slide, showing a table of dates and coordinates. 6 months before the loss of K-451 in March 1983, the U.S. Navy research vessel Thomas Washington spent 3 weeks conducting surveys in this exact area. 4 months before K-239 vanished, the USNS Mizar was operating in the Barents Sea, ostensibly studying underwater acoustics. "Research vessels," Gorshkov said slowly. "You believe they are deploying something?" "I believe they are deploying listening devices, Comrade Admiral. Not the fixed SOSUS arrays we know about. Something new. Something mobile." The room fell silent. The implications were staggering. The Soviet Navy had spent 20 years studying SOSUS. They knew where the hydrophone arrays were located, roughly. They knew the cable routes that connected them. Their submarine captains had been trained to exploit gaps in coverage, to use thermal layers and underwater canyons to mask their acoustic signatures. But if the Americans had developed mobile sensors that could be deployed anywhere, that could be moved and repositioned at will, then every assumption was wrong. The ocean was no longer a place where Soviet submarines could hide. It was a place where they could be hunted. "What are we dealing with?" Gorshkov asked. "What kind of technology?" Surikov hesitated. "We don't know, Comrade Admiral. Our acoustic specialists believe it might be some form of distributed sensor network. Autonomous devices that can listen passively and transmit their data via underwater acoustic communication. How small? Unknown. Small enough to deploy from a research vessel without detection. Quiet enough that our submarines pass within detection range without knowing they're there." Gorshkov sat back in his chair, his mind working through the tactical mathematics. If the Americans had seeded the North Atlantic with invisible listening posts, if they could hear Soviet submarines in real time, then the entire Soviet naval strategy was compromised. The USSR's ballistic missile submarines, the boomers that carried the ultimate deterrent, would be tracked from the moment they left port. The attack submarines meant to hunt American carrier groups would themselves be hunted. The Navy's entire purpose, to threaten NATO's sea lanes and protect the motherland's nuclear deterrent, was undermined. "How confident are you in this assessment?" Gorshkov asked. 70%, Comrade Admiral. There is another possibility." "Which is?" "That the Americans have achieved a breakthrough in submarine detection that we do not understand. A breakthrough so significant that our entire acoustic stealth program is obsolete." The other officers around the table shifted uncomfortably. This was the nightmare scenario, the one no one wanted to voice. That the Americans hadn't just gotten better at the game, that they were playing a different game entirely. Gorshkov made his decision. I want a special operations team assembled. We will locate one of these suspected sensor fields. We will retrieve a device, if possible. And we will determine exactly what we are facing. And the submarine fleet, Comrade Admiral. All Atlantic patrols are suspended until further notice. Our boomers will remain in their bastions under protection of surface and air assets. We take no risks until we understand what we're up against. It was a humiliating order. The Soviet Navy, withdrawing from the Atlantic, hiding in its own territorial waters. But Gorshkov had not survived this long by being reckless. As the meeting broke up and officers filed out, Gorshkov remained seated, staring at the map. 6 submarines, hundreds of men, gone. And somewhere in the depths, invisible and patient, something was listening.
January 15th, 1985, Norwegian Sea. The AS-28 Priz-class deep submergence rescue vehicle descended through absolute darkness. Inside its cramped titanium sphere, 3 men breathed recycled air and watched pressure gauges climb toward the edge of human engineering. Commander Pavel Rostov, a veteran deep-sea diver and submersible pilot, kept his hands steady on the controls. Next to him, Navy Spetsnaz diver Viktor Volsky checked and rechecked his equipment. Behind them, acoustic specialist Dr. Mikhail Timoshenko monitored an array of passive hydrophones, listening to the ocean's symphony. They were 3,200 meters deep, deeper than any Soviet military operation had ever gone. The water pressure outside was crushing, over 4,600 pounds per square inch. If the titanium hull failed, death would be instantaneous, the human body compressed to the size of a fist. They were searching for ghosts. 2 months of painstaking work had led them here. Soviet maritime patrol aircraft had photographed the American research vessel USNS Mizar during one of its oceanographic surveys. Satellite imagery showed the ship maintaining station for 6 hours in one location before moving on. Analysis of ocean currents and acoustic propagation patterns suggested this spot was ideal for a listening post. If the Americans had deployed a sensor here, Rostov was going to find it. "Bottom contact," Timoshenko announced quietly. 300 meters. Rostov adjusted the ballast, slowing their descent. The submersible's floodlights pierced the darkness, illuminating a small circle of gray mud and scattered rocks. Nothing moved. No fish. This deep, life was sparse, slow, and strange. "Deploy the search pattern," Rostov ordered. For the next hour, they traced a careful grid, flying the submersible just 10 meters above the seafloor. Timoshenko's hydrophones listened for any electronic emission, any active sonar pulse, any anomaly. They found it at grid reference Delta 7. "Contact," Timoshenko said suddenly. "Bearing 045. Range approximately 50 meters. Acoustic emission. Very faint. Low frequency." Rostov turned the submersible carefully. The lights swept across empty water, then caught something that made all 3 men inhale sharply. It was a cylinder, perhaps 2 meters long, half a meter in diameter. Dark gray, nearly black. It stood upright on 3 legs like a tripod, anchored to the seafloor. No cables connected it to anywhere. No ships floated above. It was alone, and it was alive. As they watched, a faint green light pulsed along its side. Once, twice, then went dark. "Boże mój," Volsky whispered. "It's transmitting." Timoshenko's fingers flew over his controls. "Confirmed. Acoustic data transmission. Burst mode. Frequency 3.5 kHz. Duration approximately 2 seconds, repeating every 60 seconds." Rostov felt his pulse hammering. This was it. This was what had been hunting them. Not a ship, not a submarine, not a towed array. A robot. An autonomous listening machine planted on the sea floor, waiting, listening, reporting. "Can you record the transmission?" Rostov asked. "Already doing it." "Good. Victor, prepare for retrieval." Volsky was already moving, pulling on his atmospheric diving suit, a bulky, one-man submarine that would allow him to exit the submersible at this crushing depth. It took 15 minutes to complete the preparations, check every seal, every joint, every system. When Volsky finally cycled through the airlock and swam into the open water, Rostov watched through the viewport, his heart in his throat. Volsky moved slowly, carefully, approaching the device like a bomb technician approaching an unexploded shell. The diver circled it, examining it from all angles, then reached out with his manipulator claws. He tested one of the tripod legs, trying to determine how it was anchored. The device's green light pulsed. "It knows he's there," Timoshenko said, his voice tight. "Acoustic signature changed. It's in active mode." "Victor, be careful," Rostov transmitted. But Volsky was a professional. He attached a lifting cable to the device, then produced a small, shaped charge from his tool bag. He placed it carefully at the base of one tripod leg. "Detonation in 10 seconds, Volsky announced calmly. Rostov backed the submersible away. The flash of the explosion was startling in the absolute darkness, a brief sun in the abyss. Mud billowed up in a cloud. When it cleared, the device was free, tipped on its side, the tripod leg severed. Volsky was already securing it to the lifting cable, attaching flotation bags. "Got it," he reported. "Bringing it in." They surfaced 4 hours later, the device secured in the submersible's external cargo basket. The recovery ship, a converted salvage tug disguised as a civilian research vessel, hauled it aboard under the cover of darkness. In the ship's makeshift laboratory, under armed guard, Dr. Timoshenko began his examination. The device was elegant in its simplicity. Self-contained battery power, estimated operational life of 3 years. A sophisticated hydrophone array capable of detecting submarine signatures at extreme range. A microprocessor-based analysis system that could classify acoustic signatures and prioritize targets. And a compact acoustic modem for transmitting data. "It doesn't transmit to a ship," Timoshenko explained to the assembled officers. "It transmits to other nodes in the network. They're daisy-chained. A signal passes from device to device until it reaches a collection point, probably a data buoy or a communications relay near a SOSUS cable." "How many of these are out there?" an officer asked. Timoshenko shook his head. "Impossible to say. Dozens. Hundreds. They could have seeded the entire North Atlantic. Each one costs perhaps $50,000 American dollars. For the price of a single submarine, they could deploy thousands." The implications were devastating. The Americans had not built a better submarine detector. They had built a network. They had turned the ocean into a sensing grid, a vast electronic web that could track movement across thousands of kilometers. Soviet submarines, for all their quieting technology, were still louder than the ambient background of the ocean. These devices could hear them, identify them, and report their positions in near real time.
The message was encoded and transmitted to Moscow that night. The retrieved device was packed in a special container and loaded onto a military transport aircraft. In the operations center of the recovery ship, Commander Rostov stood alone, looking at the photographs they had taken on the sea floor. The device standing there in the darkness, pulsing its green signal, patient and inhuman. They had found the answer to the mystery. The Americans weren't omniscient. They weren't listening with magic. They were listening with 100 patient robots scattered across the ocean floor, devices that never slept, never surfaced, never betrayed their presence until you stumbled directly upon them. It was brilliant. It was ruthless. It was checkmate.
Groton, Connecticut. Electric Boat Shipyard. June 1982. 2 years before the Soviets found their answer, the answer was being deployed. Dr. Sarah Chen, acoustic engineer and program director for the Naval Research Laboratory's Advanced Undersea Systems Division, stood on the deck of the research vessel USNS Mizar, watching her team prepare the first operational deployment. The device they were lowering into the Atlantic was called SURTASSLFA in classified documentation, but the engineers called them SEEDS. They were autonomous underwater acoustic sensors, the culmination of 15 years of research and $200 million in black budget funding. Chen had been with the program since its inception. She had been a graduate student at MIT when the Navy approached her advisor with a simple question. Is it possible to build a smart sonar that can identify submarines? The answer, it turned out, was yes. But it required rethinking everything about underwater surveillance. Traditional sonar, whether active or passive, had a fundamental limitation. It generated massive amounts of data, too much for humans to process. A SOSUS technician listening to hydrophone feeds would hear a chaos of sound. Waves breaking, whales singing, ships passing, ice cracking, rain falling, thermal layers shifting. Finding a submarine in that noise was like finding a whisper in a hurricane. The breakthrough came from an unexpected place: the oil industry. In the 1970s, oil companies had developed sophisticated signal processing algorithms to find petroleum deposits using seismic data. They could identify specific acoustic signatures buried in geological noise. Chen and her team adapted that technology. They built a system that didn't just listen. It analyzed. It learned. It recognized patterns. The SEEDS contained a digital signal processor running pattern recognition algorithms. They had been trained using thousands of hours of recorded submarine signatures. American boats, provided willingly for the research, but also Soviet boats, recorded during decades of Cold War surveillance. When a SEED detected an acoustic signal, it would analyze it instantly. Frequency profile, amplitude variation, propeller blade count, machinery vibration patterns. Each submarine, regardless of how quiet, had a unique acoustic fingerprint, and the SEEDS could identify it. "Device is away," the deck supervisor called out. Chen watched the cable unspool as the SEED descended into the depths. There was no ceremony, no fanfare, just another day of planting the ocean floor with American ingenuity. "How many is that?" asked Commander James Holloway, the Navy liaison officer assigned to the program. 47, Chen replied. "We'll have 300 deployed by the end of the year." Holloway whistled softly. "And the Soviets have no idea." "They're looking for submarines," Chen said. "They're looking for ships. They're looking for cables. They're not looking for autonomous sensors that don't transmit to surface vessels, don't have crews, and don't need maintenance for 3 years." It was the perfect asymmetric advantage. The Soviet Navy had spent billions building quieter submarines. They had trained their captains in sophisticated evasion tactics. They had mapped SOS-US arrays and found ways to slip through the gaps. But they had never anticipated this: a network that didn't care about gaps. A network that could be anywhere. A network that was patient, silent, and always listening. "What happens when they figure it out?" Holloway asked.
Chen had thought about this.
"They'll try to find them. Maybe they'll succeed, like they might find one or two. But by then we'll have deployed thousands. The ocean is vast, Commander. Searching for these devices would require surveying millions of square kilometers of seafloor. It would take decades and cost billions."
And in the meantime?
"In the meantime, we'll know where every Soviet submarine is from the moment it leaves port. We'll track their boomers in real time. We'll maintain constant firing solutions on their attack boats. And they'll never feel safe in the open ocean again."
Holloway smiled grimly. "The ultimate deterrent."
"No," Chen corrected. "The ultimate denial. We're not deterring them. We're denying them the ocean. Without submarine stealth, their entire naval strategy collapses. Their subs can't threaten our carriers if we know where they are. Their boomers can't hide if we're tracking them constantly. We've turned their most expensive, most sophisticated weapons into sitting ducks." The Mizar moved to the next deployment site. Over the next 3 years, ships like it would crisscross the Atlantic, the Pacific, and the Arctic, planting seeds. By 1985, over 800 would be operational. By 1990, more than 2,000. The Soviet Navy never had a chance. The technology wasn't even particularly secret once you knew it existed. The principles were published in academic journals. The signal processing algorithms were commercially available. Any advanced nation could have built something similar. But only America had the resources, the vision, and the sustained commitment to actually do it. To spend years perfecting the technology in secret. To deploy it across millions of square miles of ocean. To maintain and upgrade the network continuously. It was the quintessential American advantage. Not just having good ideas, but having the economic power and organizational capacity to turn those ideas into operational reality at global scale. As the sun set over the Atlantic, Chen allowed herself a moment of satisfaction. Down there, in the cold darkness, her seeds were listening. And somewhere in the Soviet Union, naval officers were trying to figure out why their submarines kept vanishing. They would never find the answer in time. Severodvinsk Naval Shipyard, March 1985. Chief designer Yuri Panov stood in the assembly hall of the shipyard's Submarine Design Bureau, staring at the incomplete hull of K-239, the lead boat of the new Project 945 Barracuda class. The Barracuda was supposed to be the Soviet answer to the American Los Angeles class. It was revolutionary. A titanium hull allowing unprecedented diving depth, an advanced reactor providing twice the power of previous designs, and a radical new propulsion system that promised near silence. It was also obsolete before it ever touched water. The retrieved American sensor device had been dissected, analyzed, and understood. The Technical Commission's report had been devastating. The report concluded that Soviet submarines, regardless of how quiet they became, would be detectable by the American network. The pattern recognition algorithms were simply too sophisticated. They could identify a submarine by analyzing subtle frequency patterns that no amount of quieting could fully eliminate. "We cannot out-quiet them," Panov had told the Defense Ministry.
Their detection threshold is below our ability to reduce noise. We would need to make our submarines physically smaller, eliminate all machinery, and abandon nuclear propulsion. We would, in essence, need to return to diesel-electric boats operating at walking speed. This is not practical. The room had been silent after that assessment. Now, standing before the unfinished hull of K-239, Panov faced the same group of ministry officials, Admiral Gorshkov among them. "So what do you propose?" Gorshkov asked. Panov had spent 3 months developing the answer. It was not what anyone wanted to hear, but it was the only logical path forward. "We cannot win the detection battle," Panov began. "So we must win the weapon battle. If the Americans know where our submarines are, we must make that knowledge useless." He signaled to his assistant, who pulled up a series of engineering diagrams. "We accelerate development of the Shkval supercavitating torpedo. Range 7,000 meters. Speed 200 knots. Underwater, this weapon is effectively uninterceptable. Even if the Americans know exactly where our submarine is, even if they have a firing solution, Shkval gives us first shot advantage. 7 kilometers is close range for a submarine engagement," an officer pointed out. "Then we make close range irrelevant," Panov continued. "We develop longer-range weapons, missiles that can be launched from submerged submarines, anti-ship cruise missiles with ranges of 300, 400, 500 kilometers. If our submarine is detected, it strikes before the enemy can close to weapon range. And for our ballistic missile boats? The Americans will track them constantly. They will maintain firing solutions. If war begins, our boomers will be sunk before they can launch." This was the critical question, the one that kept the General Staff awake at night. The Soviet Union's nuclear deterrent rested on its ballistic missile submarines. If those boats could be hunted and killed, the entire strategic balance collapsed. Panov took a deep breath. "We abandon the concept of hidden boomers. We accept that they will be tracked. And we protect them." "How?" "Bastion defense. We keep our missile boats in the Barents Sea, in the Sea of Okhotsk, in waters directly adjacent to our territory. We surround them with attack submarines, with surface ships, with aircraft. We create zones that are impenetrable to NATO forces. The Americans may know where our boomers are, but they cannot reach them without triggering World War III." It was a complete reversal of Soviet naval doctrine. For 2 decades, they had built submarines designed to roam freely across the Atlantic, to threaten American carrier groups, to hunt enemy boomers in the deep ocean. Now, they would retreat to fortress seas, fighting a defensive battle in their own waters. Gorshkov's face was unreadable. He was too old for this, too close to the end of his career to preside over the dismantling of everything he had built. "You are proposing that we surrender control of the Atlantic," he said quietly. "I am proposing we acknowledge reality, Comrade Admiral. We never truly controlled the Atlantic. We believed we did. The Americans have proven otherwise. They have spent 15 years building a surveillance network, while we spent 15 years building quieter submarines. We were solving the wrong problem." "And what is the right problem?" "Survival. Deterrence. Ensuring that even if the Americans know where all our boats are, attacking them carries an unacceptable price. We turn our weakness into a strength. We lure them into our bastions, into water where we have every advantage, where every NATO ship is within range of land-based aviation, where their supply lines are extended, and ours are not." The discussion continued for hours. Officers argued, engineers presented data, political commissars worried about the optics of retreat. But in the end, the math was undeniable. The Soviet Navy could not contest the open ocean against an enemy who could see everything. The only rational response was to concentrate forces, to fight from a position of strength, to make the cost of victory unacceptable. The decision was made. The Soviet submarine fleet would withdraw from the Atlantic. Patrols would be reduced to intelligence gathering only, close to home waters. The Northern Fleet would concentrate in the Barents, protected by surface vessels and land-based aircraft. The Pacific Fleet would establish a similar bastion in the Sea of Okhotsk. It was a humiliation, but it was survival. As the meeting broke up, Gorshkov pulled Panov aside. "You know what this means," the admiral said. "Yes, Comrade Admiral." "It means we lost. The Americans won the Cold War under the ocean years ago. We just didn't know it until now." Panov had no answer. Gorshkov was right. The American sensor network hadn't sunk a single Soviet submarine through direct action. But it had achieved something far more significant. It had forced a strategic withdrawal. It had broken the Soviet Navy's will to contest the seas. It had proven that the USSR could not match American technology, could not afford to compete in this invisible war of sensors and processors and distributed networks. The Soviet Union was still a superpower on paper. It still had thousands of tanks, tens of thousands of nuclear weapons, and the world's largest submarine fleet. But it had lost control of the ocean. And everyone in that room knew that without the ocean, without the ability to threaten NATO's sea lanes and protect their own deterrent, the entire Soviet strategic position was compromised. The seeds planted on the Atlantic sea floor had borne fruit. Not in sunken ships, not in destroyed submarines, but in strategic defeat. The Cold War was over. The Soviets just hadn't formally surrendered yet. December 1991, Murmansk. Captain First Rank Dmitry Volkov, now retired, stood on the pier at Severomorsk, watching the K-239 memorial ceremony. 7 years had passed since the submarine vanished. The Navy had finally declared the crew dead, lost at sea during exercises. Volkov knew better. K-239 hadn't been lost to accident. It had been lost to history, caught in the transition from one era to another, sacrificed on the altar of a technological revolution no one had anticipated. The American sensor network was no longer secret. After the Soviet Union collapsed, details leaked out. Defense contractors gave interviews. Academic papers were published. The sensors themselves, their batteries exhausted, began washing ashore on beaches from Newfoundland to Scotland, fascinating curiosities for beachcombers. The network had worked for exactly as long as it needed to. It had broken Soviet confidence. It had forced a strategic retreat. And then, its job done, it had slowly gone dark, replaced by even more sophisticated systems, by satellites and drones and technologies Volkov couldn't even imagine. He thought about Yevgeny Petrov and the 94 men of K-239. They had been good submariners, careful and professional. They had followed doctrine. They had done everything right. And they had been heard anyway, tracked anyway, hunted anyway. What had happened in those final hours? Had they known? Had they realized that something was following them, that the ocean itself had betrayed them? Had they fought? Had they tried to escape? Or had they simply died, confused and terrified, not understanding that the rules of the game had changed? Volkov would never know. The ceremony concluded. Sailors saluted. A band played the Navy hymn. The families wept. As the crowd dispersed, Volkov remained on the pier, looking out at the gray waters of the Barents Sea. It looked the same as it always had. Cold, vast, indifferent. But it wasn't the same. The ocean had changed. It had been colonized by invisible machines, wired with sensors, turned into a surveillance grid. The age of the submarine, that brief century when men could slip beneath the waves and disappear into the silent depths, was over. The Cold War had been fought in many arenas, in the skies, in space, in the deserts, in the halls of diplomacy. But its most decisive battle had been fought in the one place no one could see, in the deep ocean, in the absolute darkness, where American engineers planted their patient seeds and Soviet submariners vanished one by one. It wasn't bombs that won the war. It wasn't missiles. It wasn't tanks or planes or nuclear weapons. It was information. The simple, devastating ability to know where the enemy was, to track him, to deny him the ocean's protection. The Americans had turned the ocean transparent, and in doing so, they had turned the world. Volkov saluted the empty water where K-239 had vanished. Then he turned and walked away, an old man from an old war, leaving behind the silence. In the depths below, invisible and forgotten, the seeds still listened. For those who sailed into the silence and never returned,